We're surrounded by smart devices these days. They're literally everywhere, from our watches to our refrigerators. But have you ever actually stopped to wonder, how does all that work? How does the data from your smart thermostat get all the way to your phone? Well, today, we're going to follow that data on its incredible high-speed journey.
Seriously, think about it for a second. That little ping you get from your security camera, or, the temperature reading on your thermostat, even your step count. Every single one of them is like a tiny story. It's a little piece of the real, physical world captured and translated into the language of computers. And spoiler alert, it's not magic. It's actually this super fascinating high-speed relay race. You've got sensors, gateways, the cloud, all passing the baton. So let's do it. Let's follow that data step by step, right from the very moment it's created to the moment it pops up on your screen. All right, so every journey has a starting point, right? Ours begins at the absolute source. I'm talking about the digital nerve endings of our entire connected world, the sensors. So what is a sensor really? Well, at its core, it's basically a translator. It takes something real and physical, like, say, the temperature in your living room or the fact that your front door just opened, and it translates that into an electrical signal. And that signal, that's the basic language that all computers speak. It's the very first crucial step to making the physical world make sense to our digital devices. But here's the thing. A modern sensor isn't just some dumb switch. Nope. It's actually part of what's called a sensor node, which is basically a tiny little specialized computer. I mean, it's got a processor, a little brain to think, memory to remember things, a wireless interface so it can talk, and its own power supply. It's the whole package, ready to do its job all on its own. Okay, so picture this. We have literally billions of these tiny computers out there, right? All of them are sensing and translating what's happening around them. So what happens when they all try to talk at the same time? Well, you get a huge problem. You get a massive digital traffic jam. And when I say massive, I mean enormous. Just imagine a factory floor with thousands of sensors, or an entire city with millions of these connected devices. If you tried to send every single piece of raw data from all of them straight to a central server, oh man, it would be an absolute nightmare. Incredibly inefficient, it would clog up the entire network, and it would take forever. And that right there is the heart of the problem. The old way of doing things, what you see on the left, it creates a ton of what's called latency. That's just a fancy word for delay, for lag. It's because you're trying to shove this giant fire hose of data directly into the cloud, and for that to even work, you need a perfect, constant connection. The new way, this edge architecture on the right, it solves all of this. It's way faster, it's smarter, and it's a lot more resilient. The big question is, well, the solution is a really clever idea called computing on the edge. You can think of it like a smart middle manager, someone who steps in to prevent that digital traffic jam before it even starts. Okay, so what is an edge device? The best analogy is a bouncer at a club. Seriously, it just sits there on the edge of your local network, and it's the one that decides who gets in and who gets out. Your home Wi-Fi router, that's a perfect everyday example of an edge device. It's the gatekeeper between all of your stuff at home and the great wide open internet. Now, in the world of smart devices, or IoT, there's one specific kind of edge device that's king, the IoT gateway. Think of this thing as the on-site supervisor for all your sensors. It's the communication bridge that listens to all the little stories from the sensors, and then, and this is the important part, it decides which ones are actually important enough to get sent up the chain to headquarters. So how does this supervisor actually do its job? Well, it follows this simple but honestly brilliant three-step process. First up, it filters out all the noise. So instead of your thermostat sending a temperature reading every single second, the gateway might say, hey, just tell me if the temperature actually changes. This is huge because not only does it save a ton of bandwidth, but it also boosts your privacy by keeping all that pointless data right there at home. Okay, second, it translates. It makes sure the data is speaking the right, secure language for the trip ahead. And finally, step 3, it forwards. It sends only the really important filtered data on its way to the cloud. All right, so our little packet of data is now lean, mean, and important. It's gotten past the local supervisor, and now it's on the highway, heading for the main headquarters, the cloud. Okay, let's talk about the cloud. What even is that? Well, first off, it's not some fluffy thing up in the sky. Really, it's just a massive shared pool of computing power. Servers, storage, you name it, that you can tap into over the internet. So instead of having to buy your own ridiculously expensive supercomputer, you can just run a piece of one whenever you need it.
And this is what lets companies do all the heavy lifting, like analyzing data from millions of devices, without having to spend a fortune up front.
But the cloud isn't just one thing. It's not a one-size-fits-all deal. It comes in 3 main flavors, and these analogies here make it super easy to get. First, you've got infrastructure as a service, or IaaS. Think of that like renting a piece of empty land. You get the basics, storage, computing power, but you got to build everything on it yourself. Then there's platform as a service, or PaaS. This is more like renting a fully equipped workshop. All the tools are there, ready for you to start building your apps. And finally, software as a service, SaaS. This is the easiest one. It's like renting a finished car. You don't build anything, you just get in and use the software that's already there, like Gmail or Netflix.
Okay, let's recap. The data has been sensed, it's been filtered at the edge, and it's been processed in the cloud. We're almost there. Now it's time for the final and, you could argue, the most important leg of the entire journey, getting that information to you.
And that app on your phone, that's Mission Control. It's the command center for this whole operation. This is the end of the line for the data's journey. Now, what's interesting is your app doesn't talk directly to the sensor way back at your house. Nope. It talks to that super powerful cloud server, and the cloud is what gives you that final polished piece of information. And of course, a way to send commands right back down the line. And this talk between your app and your devices, it basically happens in 4 main ways. First, you have telemetry. That's just one-way data. Think of your thermostat sending temperature updates up to the cloud. Easy enough. Then you have an inquiry. This is when you ask a question and get a response like, hey, is the front door locked? Then there's a command. That's when you're the boss. You're sending an order like, unlock the front door. And finally, you've got a notification. That's when the system sends a one-way alert to you, like that motion-detected alert that makes your heart skip a beat. And there you have it. That's the entire trip. A real physical event, something as simple as the temperature changing or a door opening, gets converted by a sensor, filtered by a gateway, crunched by the cloud, and then delivered as a truly meaningful insight right into the palm of your hand. The journey is complete. But understanding this whole journey brings up a really big, critical question. At every single step, from that first sensor to the edge gateway and all the way to the cloud, choices are being made. Choices about what data gets collected, what gets filtered out, and where it all gets stored. So as we keep building this smarter, more connected world, we have to ask, who should get to control the path our data takes? That question, right there, might be one of the most important ones we face today.